A deadline looms on the calendar as requirements multiply, and unfinished details surface during every review meeting. Teams can work hard all week, yet still feel shocked when the schedule refuses to compress. This occurs because building software involves design, testing, documentation, and integration, which do not scale linearly. Work also expands through training, coordination, and rework when people interpret the same goal differently. The cost extends beyond a late delivery. Quality breaks when testing and documentation are treated as optional. Users then receive systems that look complete but fail under real conditions, demanding expensive repair cycles. Imagine a project where new hires join midstream, meetings fill the days, and integration defects dominate system tests. Everyone stays busy, but the bottleneck becomes shared understanding and careful verification rather than typing speed. These ideas cover staffing limits, role design, disciplined architecture, and planning for change without unrealistic schedules. This video is inspired by the Mythical Man Month by Frederick. Subscribe for more practical engineering insights. Time on a software project is not interchangeable, as some tasks must occur in sequence rather than in parallel. The man-month mindset fails when it treats people as units that can be swapped without considering training costs. When a project is behind schedule, adding more people increases the training load and the number of communication links to manage. This overhead can negate the benefits of division of labour and also slow down debugging and full system testing. A late project often triggers a cycle where leaders add staff, repartition work, and then discover that the finish line has moved. Training consumes the time of experienced workers, and the repartitioning process also discards work that has already been completed. In one instance, new people were added after a missed milestone, which then stretched testing because interfaces and responsibilities had changed. The calendar does not pause for that transition, so the project can still end as late as before staffing changed. This logic pushes planning toward early staffing, stable interfaces, and honest budgeting for testing time inside the schedule. A useful next move is to map which tasks can be partitioned, then budget explicit time for training and coordination. Large systems require many contributors, but a small, sharp core can still control the design and ensure final coherence. The key mechanism is separating decision authority from support work, allowing one lead mind to keep the system consistent. This approach assigns a chief builder who writes the critical parts and owns the technical vision end to end. Supporting roles handle editing, administration, record keeping, and tool support, ensuring the core work remains focused. In practice, a team can maintain a modest size while still producing documentation, libraries, and disciplined interfaces. That balance reduces crosstalk, as fewer people need to negotiate every design decision simultaneously. Imagine a project where one lead drafts the system plan, and an editor refines the documentation for clarity. An administrator manages staffing and reporting, while a program clerk maintains the technical records for the group. The result is a design that feels like one piece, even when many hands build and test the components. A simple next step is defining one accountable design owner and assigning support roles before the team grows. Often, second attempts become overloaded as confidence rises and every deferred feature is added to the new design. The process involves the accumulation of unnecessary features, creating a richer system that exceeds what users regularly need. Over-design increases conceptual complexity, making the system harder to learn, remember, and use correctly. Ease of use improves only when the added functionality significantly outweighs the time lost in learning and searching manuals. A practical safeguard is to insist on a coherent plan and limit features to those that fit the central concept. Clear decision-making power in a chief architect prevents committee compromises that stack options without integration. Teams can treat each added capability as a trade that must earn its place through real usage and clear benefit. This discipline protects the user experience and reduces the implementation burden that follows from uncontrolled scope. Over time, the same discipline also reduces maintenance load, as simpler systems produce fewer unexpected interactions. If disciplined design matters to you, subscribe for more ways to keep complexity under control in real projects. Communication fails when decisions remain private, as different contributors then build incompatible parts that cannot fit together. The process is simple. Decisions must be recorded, shared widely, and revisited through a regular forum. Weekly conferences work well when the same architects, users, and implementers meet, reducing the time spent catching up. Written proposals focus attention and force decisions, reducing inconsistencies created by committee drafting. When authority is unclear, meetings often produce talk without commitments, causing action to stall despite high effort. Clear vesting of decision-making power avoids compromise and delay when trade-offs cannot satisfy everyone. One pattern uses a stable meeting cadence, distributing decisions promptly so that every builder works from the same baseline. Another pattern relies on hallway conversations, but surprises can arise when different assumptions collide during integration. This idea links back to schedule reality, as shared understanding prevents rework and protects scarce testing time. A useful next move is publishing decision notes after each meeting and tying them directly to interface and design documents. Early versions of a system are often barely usable because unknown requirements and scaling limits are discovered late. Teams learn the real shape of the problem only after building something concrete and running it. Scaling from a pilot to a full product requires redesign, not patching, as early structures rarely fit the final load. Planning for a throwaway first version makes redesign deliberate instead of chaotic and reputation damaging. Teams can manage change by numbering versions and using a freeze date, so late changes wait for the next release. This quantization reduces errors induced by constant revision and gives testing a stable target for verification. Documentation supports this system by exposing assumptions and inviting criticism before code locks them in. Some organizations avoid documenting because tentative decisions feel risky to defend, even when those decisions must exist. This approach treats change as normal while still demanding discipline in how changes are proposed, reviewed, and released. A simple next step is budgeting time for an early pilot, then reserving explicit space for redesign before promising final delivery. The core shift is to respect the true nature of software work, where planning, communication, and testing are as important as coding. Late projects do not recover through additional bodies, as training and coordination increase while the calendar continues to move. Smaller teams with clear roles can maintain design coherence while still providing documentation, records, and operational support. Disciplined architecture prevents second attempts from becoming feature piles that increase complexity without improving daily use. Regular forums and written decisions keep teams aligned, ensuring that integration work does not become a last-minute surprise. Planned pilots and redesigns turn early mistakes into learning opportunities, rather than embedding them in production systems. Together, these mechanisms create calmer schedules, clearer ownership, and systems that users can learn and operate reliably. Start by identifying one fragile point today, such as unclear authority, missing documentation, or unrealistic testing time. Then add one concrete guardrail, such as a decision log, a version freeze, or a defined owner for the system concept. If you want more grounded engineering frameworks like this, subscribe and continue building systems with clearer trade-offs.